Guys, this is acceleration. We've already talked about speed and velocity and calculating that. And now we're going to do some acceleration. So if you're in my General Science Foundations class, turn to page J. We're down at the bottom where it says acceleration. Go ahead and get out your binder, paper, pencil, and a calculator and turn up your volume. All right, so acceleration. Acceleration is defined as the rate at which velocity changes. And if you remember from before, we said velocity is a change in speed, so that could be speeding up or slowing down, or a change in direction. So remember, it could be any of these things, a change in speed, a direction, or both. And remember, it could be speeding up or slowing down. We still call it acceleration when it's slowing down, but it'll be a negative number, or we do call it deceleration also. So to calculate acceleration, you're going to take your final velocity minus your initial velocity divided by time. So this formula here, A equals, and we always say velocity final, or final velocity, minus velocity initial, and then divided by time. Now just be careful when you're calculating acceleration to get this answer on top first before you divide by t. All right? So actually, before we get into problems, I want to do a little bit of the algebra for you. This is pretty tough algebra, so I'm going to just kind of give these to you guys. You guys know if you want to get rid of the t, or you do your cross multiplying, you'd have a times t equals vf minus vi, all right? And from there, it makes it a little easier if I want to solve for t. Okay, I can divide by a. Anything you do one side, you do to the other. So t is vf minus vi over a. All right. Now I want to go back to this a times t equals vf minus vi to get our vf and our vi. So now if I want to solve for vf, since this is subtracted, remember you guys told me you always do the opposite operation. So since it's subtracted, the opposite would be adding. That'll get rid of it over here. Anything you do to one side, you do to the other. So vf is going to be a times t plus your vi. And you have to make sure you multiply those first. Now, it's easiest to go from here to get VI. So if I want to solve for VI, since the AT is added, you want to subtract the AT. Anything you do to one side, you do to the other one. So VI, if I ask you to solve for initial velocity or starting velocity, it would be VF minus your A times your T. So I would just make sure you have these copied down, and you can just always refer back to them. I'm not going to make you guys memorize them. But these are going to be your formulas. So if I just ask for acceleration, it's just VF minus VI over T. And if I ask for time, here's your time formula. If I ask for final velocity, here's your final velocity formula. And if I ask for initial velocity. So you may want to pause on this and copy all these down, just those four, because you're going to be using them the next couple days. But don't worry necessarily about how I got to them. You'll probably get to that in algebra if you haven't already. All right? One other thing that I want to mention, you guys know how big I am on units. Knowing units will help you so much. All right? So units for VI or VF, any kind of velocity. Standard is meters per second, but it actually could be anything. Miles per hour, kilometers per minute, you know, all sorts of, just so long as it's a distance unit per time unit, that's going to be a speed. Time, of course, you know, time units. Time could be seconds, minutes, hours, days, and so on, just a time unit. So what happens when you calculate acceleration, since you're taking the change in velocity, okay, so you're going to say so many miles per hour minus so many miles per hour, you're going to have a speed unit on top, but then you're dividing that by a time unit, okay, let's say seconds. You know, if you talk about a car goes 0 to 60 in so long. So acceleration units are going to look a little wild because it's going to be a speed unit, like miles per hour, per time, so per second. So these are the kind of units that you're going to see. Or it might be, you know, any of these up here, remember. So it might be meters per second per second. Anytime these two units are the same, you can also write it like this, meters per second squared. So just so you don't freak out when you see that. But again, when you think about acceleration, it's the rate at which your speed is changing. So if my acceleration is 2 miles per hour per second, that means each second my speed is increasing by 2 miles per hour. So after 1 second, I'd be going 2 miles per hour. After a second, I'd be going 4 miles per hour. After a third second, I'd be going 6 miles an hour, and so on and so forth. So acceleration is going to be distance per time, or speed per time unit. All right. I know it looks kind of funky, but you guys will be just fine. All right. So this next one, here's my example, and I think Porsches are quicker than this. Um, but if a Porsche went from 0 miles an hour to 60 miles an hour in 5 seconds, which is actually pretty quick, but I know there's some faster ones out there. Problems, just like we've always been doing them. You list your knowns and unknowns. You write your formula. You plug in your numbers and your units. So let's just read the words carefully. A Porsche goes from 0 miles per hour. So it goes from this to 60 miles an hour. So 0 miles per hour has to be your initial velocity. 60 miles an hour is your final because it goes from this to that. All right, so my initial velocity is 0 miles per hour, and my final velocity is 60 miles per hour. And it says that it does that in 5 seconds. So 5 seconds is, of course, your time unit. Oops, sorry. 5 seconds is your time unit. And then it says, what is its acceleration? Always read the questions carefully. Always, always, always. That you'll have all the clues that you need. All right, so next step, I'm just going to write my formula. My formula for acceleration that has time, VF and VI, is acceleration equals VF minus VI divided by T. And then I'm just going to substitute in my numbers. You have to make sure that you put your VF first. So my VF is the 60, all right, so 60 miles per hour minus the 0 miles per hour, and all of that divided by the 5.00 seconds. These units have to be the same units here. It doesn't matter what's on the bottom, but in order to subtract units, they have to be the same. They have to be the same. So I don't think I would do anything to you unless it was a bonus or something like that. But so 60 minus 0, of course, is 60. 60 divided by 5, of course, is 12. And I'm going to go ahead and put 12.0 just because this has 3 sig figs and this has 3 sig figs. And then our units, we have miles per hour per second. So that's miles per hour per second. All right? And there's our answer for acceleration for that Porsche. Seem all right? And I think I did all that there. I listed my knowns and unknowns. Here it looks a little neater. Here's my formula. Numbers and units plugged in. Right answer, right final units. And there's a nice picture of that Porsche. All right, so next example. I go from 80.0 miles per hour on the highway to 30.0 miles per hour on the highway. I would like you guys, after we're done with the video, to try this one and bring it into class. All right, I think you should be able to do this without any trouble. So this is your tiny little bit of homework, in addition to, of course, taking all these notes. All right, so do this one before you come to class on Monday. All right, so a couple of things. If your answer ends up a negative number, which actually you would see that in example 4. So actually, I'm going to walk you through example 4 now that I think about it. I'm going to run out of time though. So let's just go ahead and get these. Sorry. Negative acceleration is deceleration or slowing down. So hint, hint, when you do that example, you're going to come up with a negative number. So like I said, be real careful. It's final velocity minus initial. Remember to think logically when you check your final answer. Do the units and the values make sense? So just be real cautious of that, okay? The next couple of things I just wanted to give you since we were here. Gravity is the force of attraction between any two objects that have mass. All right. Mass is how much matter is in an object. Volume is how much space an object takes up. Just to kind of keep all those different things straight in your mind. And we'll go ahead and wait till the next lesson to get into gravity problems. All right, see you tomorrow.